Hello, I am the Programming Dunce, and I finally got around to creating the next set of 5 videos. In this video, I am going to introduce arrays and reference-based programming. An array is a variable that contains a certain number of variables of the same type. For instance, we could have an array of 5 integers and we can access any one using the name of the array and the element number in square brackets. For any array of x elements, you would reference the element using 0 as the first element and x minus 1 as the last element. Also, arrays such as these, once declared, continue to hold the same number of elements throughout its lifetime. There are types available that act like an array but can change the number of elements it contains during its lifetime. In C++, you have std vector, Java has the array list, C# has the list, and those are just the basic types available. The last bit of information related to the array is the 2D array. Here, 2 sets of square brackets are used. In this case, we have a 5x5 array. In reality, it is a 25-element array, but we use 2 numbers in square brackets instead of the one as shown. Moving on from arrays, we have the ability to work directly with memory. C and C++ have what are called pointers and addresses. Each variable you use, regardless of type, uses some amount of memory. Memory is organized by addresses, which are hexadecimal numbers with 6 values in each digit. Every pointer, regardless of the type it points to, really is just an address. For instance, we could have floaty, and we could have a float pointer pfloaty to the address of x, well, floaty, using the address operator, the and symbol. Whenever you change floaty, accessing the value that pfloaty points to will reflect that change. Recall back in video 3 where I said that any change a function makes to a parameter is not reflected outside the function. I hinted at the time that pointers and addresses were a way around it. If a function has a pointer as its parameter, then the function can access the original variable. Any change that the function makes is reflected after the function completes. Most programs likely have to use more memory than they originally start out with. As a mundane example, the more pages you add to a Word document, the more memory Word has to use. The more tabs you open in a web browser, the more memory the browser requires. In C and C++, you have access to the malloc int function and the free functions. Malloc will give your program as many bytes as you request in the parameter, or return 0 if it failed. Free will relinquish the memory you have allocated. You want to assign malloc's return value an address to a pointer. C and C++ also require that you free the memory once you are done with it. Java and C# have what is called a garbage collector, meaning that the memory allocated is free once there are no longer any pointers pointing to it. Pointers are simply references in Java and C#, and for complicated variables are null when first declared. C++, C#, and Java also provide the new operator, which is similar to malloc in C and C++. Because C++ does not provide a garbage collector, programmers using C++ are compelled to use the delete operator for any use of new. It is also inadvisable to use delete on a malloc pointer and the free function on a new pointer. Let's turn to some code now and apply the concepts previously discussed. I have a small array of ints, and because it is such a small array, I declare variables to use in the array. In fact, I have 2 of the elements point to the same variable. The larger A larger array is a 4x4 2D array of a struct of floats to indicate their location in the 2D array. We allocate new memory using the new operator and assign the values after making sure it is not null. When working with pointers in C++, after declaring them, you'll want to assign it as quickly as possible. Otherwise, and this is true in Visual Studio, the pointer could be pointing at a random place in memory, and this could cause the underlying operating system to stop your program. Also, after any call to allocate memory, you should check to see if it is null. In such small programs such as these tutorials, this is unlikely. But in larger programs that can push the limits of your computer's memory, they should have a contingency plan in case the OS decides enough is enough. Back to the tutorial, I checked to see if it is null and if it's safe to use. And if it's safe to use, assign the floats and the new struct according to the location in the array. I then go through the array again to print their values just to make a point. Finally, as C++ and C would demand, I'll go through and delete. It is also good practice to make a pointer null post-release so you don't accidentally use it again. I'm the Programming Dunce. Thank you for watching, and join me in the next video where we will finally discuss objects, the feature that really distinguishes between C and C++.